Hi everyone, today let us learn oxidipymethane rearrangement. This rearrangement is similar to dipymethane rearrangement, but it is oxa because the substrate is a acyl group. So mainly a carbonyl group is there as a substrate. Now in this substrate mainly there is a beta gamma unsaturated ketone, and since it cannot undergo the sufficient excitation, it is going to need a sensitizer with which it can get excited to the triplet state. So this is the main basics of the rearrangement, and similar to dipymethane rearrangement, even in this we can see a 1,3 diradical as an intermediate, which is the most stable. So now let us understand the mechanism. So here this our substrate is a it's a beta gamma unsaturated. So if I label the carbon adjacent to the carbonyl as alpha, the adjacent carbon will be beta and this is going to be gamma. So it is beta gamma unsaturated ketone. So that is the substrate. And it is with the help of a sensitizer, it is going to get excited to S1 state. Now at S1 state, since it has taken the help of a sensitizer which would have given off the energy to the substrate, it can easily undergo ISC, that is intersystem crossing, and it can get promoted to the triplet state, that is T1. Now at this point here, we can look at the mechanism or how the bond cleavage and bond formation is taking place. So mainly if I number the carbonyl carbon as 1 and the adjacent as 2, and this is going to be 3 and this will be 4 carbon. So now the first step will be the bond breaking at C3 and C4 to give rise to two free radicals at carbon 3 and carbon 4. Now the next step will be the carbonyl group again will have a bond breakage wherein there will be free radical formed at carbon 1 and also at oxygen. Okay, so now when there are two free radicals, that is there are going to be two free radicals like this at C1 and at C3. Now hence it can form a cyclopropane ring structure like this. Okay, cyclopropane will be formed. Now the next step would be bond breaking at C1 and C2. So now this bond what you can see is C1 and C2. Now bond will be broken, again a homolysis or homolytic cleavage, wherein a free radical will be on carbon 1 and free radical will be on carbon 2. So here you can see how there is a a free radical formed at carbon 1 and also a free radical which is formed at the C1, and it will again form a carbonyl. Okay, so mainly here it is like this. At C1 there is it's like this. At C1 there is a free radical and at oxygen there is a free radical. And there's already bond between carbon and oxygen. Now these two free radicals will form a bond to give rise to a double bond. That is nothing but an acyl group. The acyl group will be formed back again. Okay, because at this intermediate, that is at 1,4 diradical, there was an absence of the acyl group because of the bond breaking. Now again the acyl group will be formed again. Now the last step will be, as you can see here very clearly, at these two carbon units there are two free radicals on them. Okay, so that is why here the last step will be the bond will be formed between them to give rise to the cyclopropane. So here okay, so you can see how the bond is formed here between these two free radicals, and that is how the cyclopropane ring will be formed. So overall, if you look at this mechanism, you can easily make out how there is a shift of acyl group. Okay, that is an acyl group is migrating. So when look at the substrate, okay, or the initial reactant, and then look at the product, how the acyl group has undergone a migration, and that is 1, 2 migration. So this is the mechanism of oxidized by methane rearrangement. Thank you.